you are welcome to the Science Simplifier channel. Today we are going to look at analysis of cations, and today we are going to see BCM. For B stands for barium ions, then C stands for calcium ions, and M will stand for magnesium ions. We are going to see what happens to the test solution when we add there these reagents. And we are going to start with adding dilute sodium hydroxide solution dropwise until in excess. The moment we obtain white precipitate insoluble in excess, just know at that point we are dealing with barium ions, magnesium ions, and also calcium ions. Now let us move to the next reagent. We can also add there dilute aqueous ammonia dropwise until in excess. Here we are having two observations. The first one, we can have no observable change. The moment you obtain no observable change, just know you are dealing with calcium ions. Now another observation, you can have white precipitate insoluble in excess. Just know at that point you are having barium ions and also magnesium ions. Now we can move to the next reagent. Now we can also add there any soluble sulfate. i.e., we can add there dilute sulfuric acid, or we can add there sodium sulfate solution. Now for this one and this one, we just provide us with sulfate ions within the solution. Now here we are going to have two observations. The first one, you can obtain no observable change. The moment you obtain no observable change, just know you are dealing with magnesium ions. The moment you obtain white precipitate, just know you are dealing with barium ions and also calcium ions. Now we can also add there sodium hydrogen carbonate solution. The moment you add there sodium hydrogen carbonate solution and we obtain no observable change, No observable change in the cold and on heating. Just know you are dealing with barium ions. The moment you obtain white precipitate and bubbles of a colorless gas, that turns a moist blue litmus paper red and lime water and lime water milky. Just know you are dealing with calcium ions. We can have another observation. The moment you obtain no observable change in the cold, but on heating a white precipitate is formed, and also bubbles of a colorless gas. That turns moist blue litmus paper red and lime water milky. Just know you are dealing with magnesium ions. Now we can move to the next reagent. Here we can add there ammonium oxalate solution. Followed by dilute acetic acid, or you can call it ethanoic acid. Here we are having 3 observations. At first, you can obtain white precipitate insoluble in acetic acid. Just know, at that point, you just confirm calcium ions. Now the next observation, you can have no observable change. For no observable change, just know you are having magnesium ions. And lastly, you can have white precipitate. Now at this point, white precipitate soluble in acetic acid. At that point, just know you are dealing with barium ions. Now let us move to the next reagent. Now here we can add there solid ammonium chloride followed by, we can add there 3 drops of disodium hydrogen phosphate, followed by dilute ammonia dropwise until in excess. At the moment here, we obtain white precipitate insoluble in excess ammonia. Just know that is a confirmatory test for magnesium ions. At the moment you obtain no observable change, at that point you'll be having barium ions and also calcium ions. Now let us move to the next reagent. We can also add there 2 drops of potassium chromate 6, followed by dilute sodium hydroxide solution, or you can add there, instead of dilute sodium hydroxide solution, you can add there acetic acid dropwise until in excess. At this point, you can have yellow precipitate soluble in dilute sodium hydroxide solution or acetic acid. Just now that point, you are dealing with calcium ions. You can also obtain yellow precipitate insoluble in dilute sodium hydroxide solution and also acetic acid. Now at this point, this is a confirmatory test for barium ions.